Hello, welcome to More Learn, More Teach, where I attempt to simplify the complex. Now that we know that vectors can be expressed as a function of their component vectors, it's going to be convenient for us to group these equations because they can get kind of unruly in the size that it'll take up on the page, right? So we will introduce a concept called a matrix. So a matrix is a convenient grouping of terms that will assist us in the mathematical process for solving algebraic problems. So if I have a matrix, it will have rows. So the rows are in the horizontal, and it will have columns. Columns are in the vertical. The element that is located in this position will have row 1, column 1. The element that is in this position will have row 3, column 3. The one in this position is row 1, column 3. The one over here is row 3, column 1. I'll describe matrices by the number of rows and the number of columns. Rows will come first, columns will come second. So if I have a 1 by 2 matrix, it will have 1 row and 2 columns. If I have a 2 by 1 matrix, it will have 2 rows and 1 column. So now let's see an application of matrices. So I have here two 3 by 3 matrices that I am adding together. I can only add together matrices that have the same number of rows and columns. So if this is a 3 by 3 matrix, I can add another 3 by 3 matrix. If I had a 1 by 2 matrix, I could add another 1 by 2 matrix. If I had a 2 by 2 matrix, I could add a 2 by 2 matrix. What I can't do is I can't add a 3 by 3 matrix to a 1 by 3 matrix. That doesn't work. So they got to be the same in order to do this addition, because I'm going to add each position to the position in the other matrix to get my final answer. So I take this position plus this position equals the value in this position. This position plus this position equals this value in this position. If I didn't want to use a matrix, I could show this system of equations in algebraic form. So here I have a11 times x hat plus a12 times y hat plus a13 times z hat. That vector plus this vector is going to equal to this vector. This vector plus this vector equals this vector. This vector plus this vector equals this vector. So you can see the appeal of using a matrix because it's going to take a lot less space to do the same system of equations. Let's look at how to multiply matrices. So in this example, I have a 2 by 2 matrix multiplied by another 2 by 2 matrix. In multiplication, you don't have to have the same number of rows and columns. What you have to have is the same number of rows of the first one has to equal to the columns of the second one, and we'll see why in a second. All right, so here I have A11, A12, B11, B21. When I multiply these two matrices together, the first element is going to be the dot product of this set and this set. So I will take this and dot it with this to get the inner product of this position. So I take the first row, dot product with the first column, gives me the value that is in the 1, 1 position of the answer. For the next one, I will dot the first row with the second column to get the 1, 2 position of the answer. Next, I will dot the second row with the first column to get the answer for the 2, 1 position of the multiplication. And finally, we will dot the second row with the second column to get the 2, 2 position of the answer matrix. Thank you for watching my video. Please like and subscribe. If you have any questions that I can help you out with, I'd be happy to try and answer your questions. Send me an email at morelearnmoreteach@gmail.com.